we are looking at one of my favorite rules today. That is the difference quotient. So this rule is the rule we will use anytime we have a complicated fraction or a problem in which we have some sort of division that we cannot eliminate using the techniques we just used in the Kahoot. So, there is a funny little saying that we're going to learn today, and hopefully it is something that will stick with you, and you'll be saying it in your head every time you use the quotient rule for the remainder of the year. So, the quotient rule says that the derivative of a quotient is the denominator times the derivative of the denominator, all divided by the square of the denominator. So it should be typed out for you on your notes packet, right? I didn't make you write all that down. So then the quotient rule, in terms of function notation, is given down there at the bottom. So in terms of function notation, it is g f prime minus f g prime all over g of x squared. So f divides g becomes g of x f prime minus f of x g prime all over g of x squared. Or the infamous saying that I'm going to teach you, which is much smoother to say and learn. So if we are trying to find the derivative of f of x divided by g of x, we're going to think of HIdHO, HIdHO, it's off to class you go, where you have a higher part of the function and a lower part of the function. So high is up top because it's high in the sky. And then we have ho because you use a hoe to scoop up the farmland and the ground. So it's HIdHO. So the derivative of f of x over g of x becomes HIdHO minus HODI all over HOHO. Why does that feel backwards? So let's go back. Pretty sure as I just said that, I wrote it backwards. HODI minus HIdHO all over HOHO. So it's the bottom times the root of the top minus top times the root of the bottom all over the bottom squared. Sorry about that. I wrote it and I was like, this feels so wrong. HODI minus HIdHO all over HOHO. So after you write it, now I'm going to make you all say it. So on the count of 3, ho, then you're going to say HODI minus HIdHO all over HOHO. So 1, 2, 3. Ho, hi, minus hi, all over. Wow. I am glad we are not the choir. We got some great baritone in there. So again, you need to get that in your head as you're saying this. You're going to be like, HODHI, derivative of, so it's HODHI, bottom derivative of top, bottom derivative of top, minus HIdHO, top derivative of bottom, top derivative of bottom. So the D stands for derivative. D stands for derivative. HODHI minus HIdHO all over HOHO. So again, we're looking for the derivative of this function. So it's HO, so you write x squared plus 1, DHI, so derivative of x squared minus 1 is 2x, minus, here's where you have to be super careful. A lot of us in the difference quotient did not appropriately distribute a negative. You lost it. You wrote it. You forgot your parentheses. That negative distributes to all parts that follow that negative because there is a bracket around those functions. So it's HODHI minus HI. So that's like x squared minus 1 in parentheses. DHO, so derivative of the denominator. So all of that's bracketed and grouped together. So HODHI minus HIdHO all over the denominator squared. Do not FOIL the denominator. So HIdHO, do not FOIL the denominator. Everybody wants to FOIL. Don't FOIL. Leave it as is. Also, you cannot cancel that denominator with the x squared plus 1 up top. The numerator is in like numerator jail because there is a minus sign between them. So order of operations, say you have to clean up that numerator before you can cancel with your denominator. Or your denominator has to go under each term with the minus sign. Like I can't just magically cancel those. Doesn't work. So back to the task at hand. Let's clean up that numerator. So we're going to distribute 2x. We're going to distribute 2x. Then you can distribute a negative. So we get 4x quantity x squared plus 1 squared. Anybody want to see it using the definition of the derivative to prove that the quotient rule works? Yeah, that's what I thought. In all honesty, I didn't really want to do it either, but I would have. That's it. So I said, don't FOIL. You're done. So, once again, HIdHO, HIdHO, it's off to calc you go. Let's HOdHI, then HIdHO. So you got x cubed plus 6 times derivative of the numerator, 2x plus 1 minus the top times derivative of the bottom. All over the bottom squared. The minute you write f prime of x equals, you gotta write it all. Everybody wants to be like, oh, just do the denominator at the end. If you're putting f prime of x equals, you have to keep the denominator on every line, all the way through, just like you had to keep the limit on every line, all the way through. So like the very next line, I'm writing an equality statement. So it's going to be equals. We're going to clean up. So now you get to FOIL. X cubed times 2x. Because we're going to be careful about that negative. It's going to distribute to every term inside. So you don't have to put that bracket. But you got to know that if you drop that bracket now, that negative has to go to every term. So it becomes negative 3x to the fourth minus 3x cubed plus 6x squared all over x cubed plus 6 squared. So 2 minus 3 gives a negative x to the fourth. X cubed minus 3x cubed gives a negative 2x cubed. 12, no, where's my x squared? 6x squared. Then you have 12x and 6. This is not like before when you did the definition of the derivative and a whole lot of stuff canceled out. A whole lot of stuff isn't going to cancel out anymore. Good? Yeah. All right, so we have f of x equals x minus 3x over square root x all over square root x. So, yes. We got HODHI. You got two choices with the d high part. 3x square root x, you could treat like a product rule. So it would be first times root of the second plus second times root of the first. What else could I do to the 3x square root x? Go ahead, Brooke. Exactly. You could bring that x, because it's like to the power of 1. That's to the power of 1/2. So you add them together, and you get to the power of 3/2. So 3x times square root x is really like 3x to the 3/2, because again, you can think of it like being the square root of x cubed. We know the square root of x cubed simplifies to x square roots x. It's like what I'm teaching in Algebra 1 right now. So now taking the derivative of that is much easier than a product rule. So it's HODI. So it's now 3x times 3/2 minus 1. So to the 1/2. So HODI minus HI. HIdHO. All over HOHO. Three times 3 is 9. Halves square root x. 1/2 times x. So you get a negative 1/2. X times x to the negative 1/2 would give us x to the 1/2, which is kind of like another square root x. 3 times 1/2. Distributing that negative turns this to a positive. So you have a negative times a negative times a positive. So you get a positive 3/2. And again, x to the 3/2 times x to the negative 1/2 gives x. And this is all over the square root of x squared, which is x. All of these pieces right here would be considered what? Good, Brooke? Oh, you're just stretching? Okay. Okay, let me finish through it and then we'll go. So we have square root minus 9/2 minus 1/2. So a negative 9/2 and negative 1/2 gives negative 10/2, which is really just negative 5. Sorry, that one should just be an x. Okay. So 1 minus 1/2 gives 1/2. 9/2 and 3/2 gives 6/2. So 6 divided by 2 is 3. So we get minus 3x all over x. And then now, because you have a single base and a top, you can split that. So x to the 1/2 divided by x gives 1 over 2 square roots of x, because 1/2 minus 1 is negative 1/2. So that goes to the bottom, minus 3, because x over x is 1. So would you say this problem is easy, medium, or kind of complicated because you have all those radicals and exponents and positives and negatives and fractions?
Darian Phones, Tatum Gerva, and Mason Scott, please report to the office. Also, Austin Philly.
Yes. So that is exactly what I was hoping someone suggested. And I know it's hard to hear because one, Maddie's back by me, and two, there's a announcement going on. But the question was, hey, why at the beginning didn't we just break this apart like we did at the end? So what you'll notice is at the end, I took that denominator that was a single term and split it among the numerators. So way back here, let's get rid of all that icky messy. We'll leave our blue final answer to compare. So it's kind of like yesterday, right? There are times when it is easier to recognize algebra at the beginning. You could take this singular denominator and rewrite it under all the numerators. And now, look what happens before I even do my calc. I get f of x equals x to the 1/2 minus 3x. Who wants to take the derivative of that? I do. I did not want to take the derivative of the other one. It was messy. It was complicated. You had exponents and fractions. But like that, I will gladly take the derivative of. So it is very important when you get a problem to understand mathematically, can I simplify that before I derive it without breaking laws of algebra? Like I didn't break any laws in that problem. All I did was take my denominator, divide it among my numerator, which is a polynomial divided by monomial, which is valid. And now my derivative is 1/2 x to the negative 1/2 minus 3. And oh my goodness, in 2 steps, I'm at that final answer. The quotient rule, like the product rule, isn't always the smartest rule. You are smarter than any rule created. You need to know how and when to simplify to make the math the best it can be for you. Does that make sense? I'm not going to look at you on your quiz and be like, hey, that's the one you should break up. Practice and repetition will help get you to that point. Let's take this derivative now and make the connection back to where we very first started. One of the first things we started talking about was equation of tangent lines. The equation of the tangent line represents the equation that represents the slope to a point on a curve to allow me to find the rate of change at a particular point on that curve. So we're going to take that answer And we're going to find the equation of the tangent line to a point with that answer. So the original function, f of x, had the point 1, negative 2 on it. We found f prime of x to be 1 over 2 square roots of x minus 3. So we would want to find f prime of 1. I need to know what is the slope of the tangent line at that point. So the slope of the tangent line is negative 2.5. I personally hate decimals in equations of lines, so I'm going to write it as negative 5/2. Because again, that gives me the idea that, okay, the slope of this line is going down 5 over 2, down 5 over 2. All right, that's not super steep, but it's kind of steep. It gives me a better understanding of the steepness of the line and what is happening at that point. So the equation of the tangent line would be y minus a minus 2, negative 5/2, x minus 1, or y plus 2, negative 5/2 x, plus 5/2. And if you want to put it in slope-intercept form, you get negative 5/2 x plus 1/2. Yeah. You could even have left it like with the positive 2. Yeah. Yep. So we're going to look at examples as we move further that involve tables. This is kind of like a table, but it's a summarized version of it. So you're given 4 pieces of information. You're given f of 5, g of 5, f prime of 5, and g prime of 5. So you're given the original function and its point and the derivative of that function at that point and its numerical value. We can use these 4 pieces of information to find lots of different derivatives. So the first one says, find the derivative of f times g at the x value of 5. That's what that's saying. It's saying find the derivative of f times g at x equals 5. F times g is a multiplication, right? So if it's multiplication, I need the product rule. So the product rule says first, so that would be f of 5 times derivative of the second, so that would be g prime of 5 plus the second, so g of 5 times derivative f prime of 5. Because it all goes back to the product rule that says f times g, its derivative is equal to f of x times g prime x plus g of x times f prime x. First times derivative of the second plus second times derivative of the first. Now, all I'm going to do is go up to those givens and replace the f of 5, the g prime 5, g of 5, and f prime 5 with values. So f of 5 is 1, g prime 5 is 2, plus g of 5, which is negative 3, times f prime 5, which is 6. So you get 2 minus 18, which is negative 16. Okay, today's the quotient rule. So why wouldn't we look at these examples with quotients? So you have f divides g at 5. So again, HOdHI. So g of 5, derivative of the high, so f prime 5. HOdHI minus, everybody wants to make it a positive. HOdHI minus HIdHO. All over. HOHO, or denominator squared, which is g of 5 squared. Let's plug in some numbers. G of 5 is negative 3. F prime 5 is 6. Minus f of 5, which is 1. G prime 5, which is 2. All over g of 5, which is negative 3 squared. So a negative times a positive is a negative 18 minus 2. A negative number squared is always a positive. So you get negative 18 minus 2 over 9, or negative 29ths. So again, that means that f divided by g prime at 5 is equal to negative 29ths. That's what that answer represents. It represents the derivative of f divided by g at 5. Do we anticipate that g divided by f prime at 5 will be the same, different, flipped, totally unrelated? What do you think, Chase? Yeah, it's going to be totally unrelated. All right, let's go. HOdHI. Minus HIdHO. All over. HOHO. F of 5 is 1. G prime of 5 is 2. Minus negative 3 times 6. All over 1 squared. So again, watch the fluidness with which I write my values. I keep equal signs between them. I have an equal on the line above. I write an equal in the line below. Again, notation is critical. That's something we have to get really a lot better at. I notice a lot of times we might know what we're doing, but our mathematic is like scattered and everywhere. If the fluid motion of the math doesn't make sense, then AP will not give you credit. So you're going to notice, like right now, I've kind of been yelling or like marking on your test, not true, watch your equals, like putting little hints and marks. If you don't like equal signs, you can use arrows. So again, if you don't like an equal sign, you could use an arrow. So you could be like, okay, this goes to that, this goes to that, this goes to that. But if you use an arrow at the beginning, you cannot magically use an equal at the end. So you just need to get a consistent way of doing it and make that be your way. Questions at all on any of the quotient rule, product rules, etc.? Sorry. So we're going to do two things. We're going to do these textbook problems and then the review handout on the next page. And for the textbook, let's just hold off and we'll actually do just the evens on the textbook. So I'm going to gift you fewer textbook problems. Do 14 to 28, the evens in the textbook, since I gave you that handout. Hey, that wasn't bad for writing with a mouse. Okay, so 14 to 28 evens, and then the next handout in your packet.